ಎಲ್ಲ ನನ್ನ 12th ಕ್ಲಾಸ್ ಸ್ಟೂಡೆಂಟ್ಗಳಿಗೆ ಮತ್ತು ಸೈನ್ಸ್ ವಿಭಾಗದಲ್ಲಿರ್ತಕ್ಕಂತಹ ಸ್ಟೂಡೆಂಟ್ಗಳಿಗೆ ಈ ಒಂದು ವಿಡಿಯೋಗೆ ಸ್ವಾಗತ ಸುಸ್ವಾಗತ. ಕೆಲವೊಂದು ವಿದ್ಯಾರ್ಥಿಗಳಿಗೆ ಫಿಸಿಕ್ಸನ್ನು ನೆನಪಿನ ಶಕ್ತಿಯಲ್ಲಿ ಹೇಗೆ ಇಟ್ಕೊಳ್ಳೋದು, ಆ ಫಿಸಿಕ್ಸಲ್ಲಿ ಬರುವಂತಹ ಇಂಪಾರ್ಟೆಂಟ್ ಕ್ವಶನ್ಸ್ಗಳು ಯಾವ ಅಂತ ಗೊತ್ತಾಗ್ತಾ ಇರಲ್ಲ ಮತ್ತು ಅವು ತಿಳಿತಾ ಇರಲ್ಲ. ಆದ ಕಾರಣ ಇವತ್ತಿನ ಈ ಒಂದು ವಿಡಿಯೋದಲ್ಲಿ ಈ ಸಬ್ಜೆಕ್ಟ್ನಲ್ಲಿ ಬರುವಂತಹ ಅಷ್ಟು ಇಂಪಾರ್ಟೆಂಟ್ ಲಾಸ್ ಅಂದರೆ ನಿಯಮಗಳನ್ನು ಇವತ್ತಿನ ಈ ಒಂದು ವಿಡಿಯೋದಲ್ಲಿ ನಿಮಗೆ ವಾಯ್ಸ್ ರೆಕಾರ್ಡ್ ರೂಪದಲ್ಲಿ ತಿಳಿಸ್ಕೊಡ್ತಾ ಇದ್ದೀನಿ. ಈ ಒಂದು ವಿಡಿಯೋ ನಿಮಗೆ ನೆನಪಿನಲ್ಲಿ ಇಟ್ಟುಕೊಳ್ಳುವಂತಹ ಒಂದು ಕೆಲಸವನ್ನು ಮಾಡುತ್ತೆ ಅಂತ ಹೇಳ್ತಾ ಈ ವಿಡಿಯೋನ ಎಲ್ಲೂ ಸ್ಕಿಪ್ ಮಾಡಿದೆ ಸೈನ್ಸ್ ವಿಭಾಗದಲ್ಲಿರ್ತಕ್ಕಂಥ ವಿದ್ಯಾರ್ಥಿಗಳು ಈ ವಿಡಿಯೋನ ಕೊನೆ ತನಕ ನೋಡಿ ಅಂತ ಹೇಳ್ತಾ ಇವತ್ತಿನ ವಿಡಿಯೋನ ಶುರು ಮಾಡೋಣ ಬನ್ನಿ. ಸ್ಟೇಟ್ ಆ್ಯಂಡ್ ಎಕ್ಸ್ಪ್ಲೇನ್ ಕೂಲಮ್ಸ್ ಲಾ ಇನ್ ಎಲೆಕ್ಟ್ರೋಸ್ಟ್ಯಾಟಿಕ್ಸ್. ಸ್ಟೇಟ್ಮೆಂಟ್: The force between 2 point charges is directly proportional to the potential product of magnitude of charge and inversely proportional to the square of the distance between them. The direction of the force is along the joining the two charges. Explanation: Let Q1 and Q2 be the magnitude of the two charges square by a separated by a distance r. Let F be the force between them. From Coulomb's law, F is directly proportional to Q1 Q2 divided by r square. F is equal to 1 by 4 pi epsilon naught Q1 Q2 divided by r square, where epsilon naught is the absolute permittivity of free space. Next question. Write Coulomb's law in vector form and explain the symbols. Direction F is equal to 1 by 4 pi epsilon naught Q1 into Q2 divided by r square into r cap, where r cap is the unit vector in direction of F. Q1 and Q2 are the magnitudes of the charges. R is the distance between the charges. Next law. State and explain Gauss's law in electrostatic. Statement: The total electric flux through a closed surface in free space is equal to 1 by epsilon naught times the total charge enclosed by the surface. Explanation: Let Q be the total charge enclosed by the surface. The from Gauss's law, total electric flux Q divided by epsilon naught, where epsilon naught is equal to permittivity of free space. Next law. State and explain Ohm's law. Statement: The current in a metallic conductor is directly proportional to the potential difference applied across its ends, provided the temperature and other physical conditions of the conductor are kept constant. Explanation: Ohm's law is given by I is directly proportional to V. I is equal to V by R, where I is the current in the conductor, R is the resistance of the conductor, V is the potential difference applied across ends of the conductor. Next question. State and explain Kirchhoff's junction rule of electrical network. Statement: The sum of the current entering the junction is equal to the sum of the current leaving the junction. Explanation: In the figure, I1 and I2 are the currents entering the junction O, and I3 and I4 are the current leaving the junction O. From Kirchhoff's junction rule is equal to I1 plus I2 is equal to I3 plus I4. Next question. State and explain Gauss's law in magnetism. Statement: The net magnetic flux through any closed surface is 0. Explanation: In the figure, S is the closed surface, direction B is the uniform magnetic field, delta direction A is the small area element, Theta is the angle between direction B and delta direction A. From Gauss's law, the total magnetic flux through the closed surface is given by closed B is equal to summation B delta A cos theta is equal to summation direction B into delta direction A is equal to 0. State and explain Lenz law. Statement: the polarity of induced EMF is such that it tends to produce current which opposes the charge in magnetic flux that produced it. Explanation: when the north pole of the bar magnet is moved towards the coil, EMF is induced in the coil. This induced current in the anti-clockwise direction through the coil so as to generate north pole that opposes the movement of the magnet. When north pole is moved away from the coil, EMF induced again. This induces the current in the clockwise direction through the coil so as a generate north pole. It opposes the movement of the magnet. Next question. State the laws of refraction or state Snell's law of refraction. First law. The incident ray, the refracted ray and the normal draw the refracting surface at the point of incident all lie in the same plane. Second law. The ratio of the sine of the angle of incidence to the sine of the angle of repel. Next, state and explain Malus law. Statement: when a beam of completely plane polarized light is passed through analyzer, the intensity of transmitted light is directly proportional to the square of the cosine of the angle between the pass axis of polarized and analyzer. Malus law is given by I is equal to I naught cos square theta. I naught, intensity of light emerged from polarizer. I, intensity of light emerged from analyzer. Theta, angle between the pass axis of polarizer and analyzer. Next question. State and explain Brevester's law. Statement: the refractive index of the medium is equal to the tangent of the Brevester's angle. Explanation: Brevester's law is given by n is equal to tan, where n is the refractive index of the medium, n is the Brevester's angle. Biot-Savart's law. Statement: the magnitude of magnetic field dB at the point P is directly proportional to the current in a current element, directly proportional to the length of the current element, directly proportional to sin theta, inversely proportional to the square of the distance between P and the current element. On combining all the four factors, we get dB is directly proportional to I dl sin theta divided by r square. dB is equal to u naught by 4 pi into I dl sin theta divided by r square, where u naught is equal to permeability of free space. Explanation: in the figure, xy is the current carrying wire, I is the current in the wire, dl is the length of the current element, dB is the magnetic field due to current element, P is the point at which dB is to be calculated, r is the distance between current element and P, theta is the angle between the direction of dl and r.